Hello and welcome to my project for the Networking Capstone final semester project course for the NESA program. My name is Shaheer and this is the Cloud Provisioner. The Cloud Provisioner project is a comprehensive Django-based web application designed to streamline and automate the process of provisioning cloud infrastructure across three major cloud providers: Amazon Web Services, Microsoft Azure, and Google Cloud Platform (GCP). The application offers a user-friendly interface allowing clients to input specific requirements including server types, storage, and budget constraints, facilitating the effortless deployment of network and server infrastructure. Behind the scenes, Cloud Provisioner leverages SDKs from all three providers: AWS, Boto 3 Python library, Azure SDK Python library, and GCP Python library and they're used to dynamically generate and provision requested infrastructure, emphasizing flexibility and choice for clients. Security, automation, and user communication are prioritized throughout the secure interactions with the cloud provider APIs, robust error handling, and the generation of clear documentation and user communication materials. Additionally, Cloud Provider acknowledges user responsibility by incorporating a disclaimer, making it clear that the application is not liable for any mistakes or errors that may occur during the infrastructure provisioning process. The project aims to provide a cutting-edge and customizable solution for diverse range of clients with various infrastructure needs, contributing to efficient and accessible cloud deployments across different cloud environments. So before I get started, I'd like to show you the GitHub repository for this project. You can access it via this link. So you can clone the repository using this link right here. Another very important thing is this contributing.md file. So this is where you can clone and have the project locally on your local machine. So it shares all the steps that are required for this to work, including, making sure you have Git installed, installing a virtual environment and creating a virtual environment, then forking the repository, also the different OSs that you can do this on and the specific commands. And then the most important part are the dependencies. So if you go into the requirements.txt file, this is where I have all of the dependencies for this project. This includes all of the dependencies from Django to Pillow to the SDKs, Boto 3 SDK, Azure SDK, and different dependencies that are needed, like setup tools, typeguard, TZ data, etc. Wheel as well, etc. So again, contributing a MD file, it shows how you install all of these dependencies in your specific environment. That way you can have this project work locally from your computer at home. So that is basically how to set up the project. Now let's get into the project itself. So here's the landing page for the project, and you might be wondering, how can you access this? Well, you can access it via this link right here. It's how you access the virtual machine that it's on. Since this is a cloud-based project, I decided to deploy the application on my favorite cloud provider, which is AWS. I can show you that right now over here. If I go into the console for AWS, if I go into the console for AWS and I go into the instances, you can see that there's an instance running. This is where I have my infrastructure in. This is where my app is located. It's located in Canada Central region. It has a public IP, which is what is used to access the application. It is on the T2 micro instance type, which is very cheap, which is why I chose it, because I ran out of my free tier. So again, it's in a subnet, it's in a VPC autoscaling group, uh, and I will add other instances to make this more scalable as well. So for simplicity's sake, I just added one instance with the infrastructure on it for now. This is what I named it. And if I go into the instance connect, which is connecting to the instance itself, uh, using the private IP. So this is not the public IP, as you can tell. It's a private IP which I'm connecting to. And over here, I did all the steps that are in contributing.md. I forked the repository and I ran it. Got all of the dependencies and I ran the server and I got it working. So um, over here you can see that it is running on this link right here. It's not secured, so that's why it's HTTP and not HTTPS, just for you know, simplicity's sake. So over here it's running. Again, if I go into the landing page, there's the link, and just to show you, if I refresh the page now, then it will update right here, just to show that it's running off of AWS and not my local machine. So again, if I refresh, there's a new entry. So it is running on AWS, and so let me walk you through what the forms look like. So here's a landing page. It gives you a disclaimer, and it gives you a summary of what the project is and what you can expect from it. So let's jump right into it. So AWS, Azure, and Google Cloud, those are your three choices. So let's start off with the first one, AWS. And here, again, you can choose which service you want. And for the form down below, this is where you will input all of your form details. So just to make one thing clear, every cloud provider is very similar and very different in their own way. Just for an example, AWS, it asks for an access key and a secret access key to access AWS resources through the SDK, while Microsoft asks for a client ID, tenant ID, subscription ID, and a client secret ID. Same with Google Cloud. Google Cloud is a little bit different. Google Cloud uses GCP credentials in the way of a JSON formatted file, which I will explain later on when we come into the GCP section. But I just want to iterate that each cloud provider is different. They all need different parameters to run. Most of them are similar, but just to show you, AWS compared to Azure, Azure has much more many fields because Azure expects more parameters for the instance to run. Azure has more fields, like I said. Google Cloud and AWS, they have less fields and more defaults, so that way I can leave things null and make it as user-friendly as possible, if that makes sense. So yeah, that's basically what the form looks like. It's very simple. There are three form pages for Google Cloud, Microsoft Azure, Amazon Web Services. You enter the form, and when you submit, then the integration process happens in the backend. And when you go to your cloud page, then it will show up over here. So there's your Google Cloud page, your Azure page, your I'll just refresh this very quickly just before we continue, and our Amazon AWS page. So that's what the user faced GUI or form web-based HTML page looks like. All right, moving into the nitty-gritty details of this application, the place where all the hard work happened over the last couple months, the actual Django application itself. I'd like to start off with the URL page because it's the most easy to describe. So over here are the URL patterns of each web page that is available. So for example, as soon as you enter the website, you will be confronted with the choose cloud page. This is because there's no really path. It is just as soon as you enter the URL, this is what shows up. So there are other path arguments like AWS, which takes you to the AWS deploy page, and the AWS deploy function, which we'll get into. Azure, which takes you to the Azure function and Azure HTML page, and vice versa. So I'll give you a quick demonstration of this. So again, if we go to the website directly, it will just be choose cloud, which is what is right here. So again, just the URL. If we enter it, it shows up as the main landing page. If we go back into the paths, then when we add this path into our URL, then it will show as the AWS deploy page. So if we go ahead and we add that to our page, again, add our slashes correctly, and if we press enter, then it will take you to the AWS page, and so far so forth. If we go with Azure, it will take you to the Azure page. If we go to GCP, it will take you to the GCP page. So that is how the URL works. Hope that made sense. Let's move on to the forms field. So, sorry, not forms field, the forms.py file. This is where all the integration happens. This is where the form fields are initialized. This is where they are created, where they are processed. So let's start off with the AWS deploy form, the class. So this is where the form fields are located. So as you saw on the form, if I go back to the form and I go to AWS, you can see the access key, secret key, virtual name, AWS region, availability zone, AMI-ID, user data, setter blocks, all that. They all come from this form field, which is then rendered through the HTML page. So there are the access keys with a help text that you also see on the page. And yeah, so basic stuff. If it's required, I chose true. If it's not required for the actual instance to run, then I have set it as false. For example, user data and monitoring, they aren't incredibly necessary for the instance to run, so I have them as false. So yeah, this is how the forms work specifically. These are all the fields that are in the form. And again, all cloud platforms are very similar and very different in their own way, and that can be shown through this form field as well. Just like there are credentials in AWS, there are credentials for Azure. So the Azure credentials, as I stated before, the client ID, client secret ID, tenant ID, subscription ID are required. Then there are extra parameters that are needed for Azure. These are all the virtual machine details, IP address. Again, Azure has many more parameters that are required as compared to AWS. AWS has more defaults, so it's easier to configure and it's more user friendly. Azure has a bit more, so that's why there are more fields, and there are similar fields for the GCP platform as well, with the credentials right there. So yeah, this is where the form fields will take the form inputs and they will throw them into the views.py page. This is a very important page. This is where the functions happen. This is where the main integration of the form takes place. So if we start out from the top, these are all, you can say, dependencies and modules that are required for this thing for the functions to work correctly. So for Azure, these are which are required, the Boto3 required for the Python SDK for AWS. So let's get started. For the AWS function, so each of these functions, there's one function for AWS, there's one function for Azure, and there's one function for GCP. All these functions are very similar. So for example, if I start off with the AWS deploy function, again, this function is addressed in our URL right there. So as soon as you click AWS, it runs this function and it runs the HTML page. So again, if we go to views and the exact function of AWS deploy, this is where it gets interesting. So from the form, so again, as soon as we define the function, we start off with the form and we get the form name. So again, the form name, AWS deploy for this specific class. And this is where we check if the form is valid. And we get all of the form input and put them into specific variables that are AWS specific. So we take the access key from the form and we create a variable, and we take the input or the input from the user on the form and we put it into this variable, which we can use later on, as you can see here. So each of these fields are used in the form. Nothing in the deployment process is static. There is no static. It is all dynamic. It is all taken from the form details. So there are try and excepts for each function for error handling. So I can know if the instance fails, then why it failed, why it happened. So we start off with the credentials. Every single time it creates a resource in AWS, it requires the AWS access key and secret access key. And it also requires a region for where it's going to happen. So it creates the VPC first. This is the code that was required to create the VPC. Then it creates the subnet, and again I put this in logical order so it makes sense for AWS how AWS would do it. First you create the VPC, then the subnet. If you do it the other way, then there are contradictions that happen. It took me a while to figure that out as well, but it had to be in order. Then you create the security group and then the instance at the end. So again, Boto3 for all the resources. Again, it uses region, access key, secret access key for authentication and authorization. And for the instances dictionary, this is what was required. So image ID, minimum count, maximum count, instance ID, and again, all of these are taken from our form fields, which are over here. So all these variables are taken from there. Nothing is misplaced. Nothing is static. So everything is taken from the form fields. When the code gets submitted, or when the user press submit, all this takes place, and then at the end, if there is an error, then the error is shown, and this error is directly taken from the SDK, the exceptions, and if it's a success, then the success message shows up. That's pretty much the format for all three forms. It's just with different variable names and different resources. So for example, if there's a resource group in Azure, there's a security group in AWS. They're just different names. So again, for authorization and authentication for Azure, we need these 4 pieces of credentials, and this is where the credentials are tested, and then they start with the resource creation down below. Again, everything is taken from the form. so Azure deploy form. Again, I can show you very quickly the Azure deploy form right there. So it takes all the form fields from the Azure deploy form, and it basically says that if the form is valid, it tests the form details. It takes the form cleaned data, and it puts them into the variable which is Azure specific, which Azure tests and it keeps. So all of the data is then taken from the form data. Again, the credentials all user provided. Then it creates first the resource group right here. Print statement to go along with it. Then it creates the networking information, the virtual network, etc., the required subnet, IP address, the NIC, and then finally creates the virtual machine at the end, similar to AWS. Obviously, it takes more parameters, including SKU, version, publisher, offer, all of that. And they also have additions for admin username and password, which they do not have for AWS. So that's where they also differ. And yeah, so if it's a success, it'll create the print statement, and if it does not, then it'll display the error. So very similar for GCP. It's all very similar. Again, it takes them from the form fields, then it uses the credential, and then it submits. One important thing for the GCP is that it does not take credentials like hashed credentials. It does not. It takes a JSON document. You can find this on, so if I go to the Google Cloud Platform, I go into IAM and admin. Right here, if I go into service accounts, I have created a service account for my application, and most Google Cloud users have multiple service accounts. From there, I have given the account permissions and roles to create instances, resource groups, subnets, etc. So it has full permissions. So this is basically what is required to authenticate the SDK or what we are trying to do for resource creation. So basically, what it wants is a key in the form of a JSON file. So I already have keys. I've already done this, but basically you would add a key. You would create a new key in the JSON format. And basically what I have done is I have made it so that the user can submit the GCP credential as the file itself. Not the file, but the file contents. So I make it easier for the user and make it more difficult for myself because I have to take out the specific information from the file through my code. But again, it's for user usability, so it's easier for the user. But yeah, so basically all, if it's a success, it prints success. If it's a failure, it shows the error Y, and it's very similar for all three. So that is basically where the main functions reside for this project. That was this is basically what the nitty-gritty details are like. And one more thing, if you're wondering where the actual user sees this information, it's in the first function. So the first function is called choose Google Cloud. This will enter as soon as you click the first URL. So there it is, choose Google Cloud, and it will display this HTML and CSS basically configuration that I have set up. I created this with the 3 URLs, the disclaimer, and yeah, so this is basically the same for all of our files. This is the base HTML. This is the HTML that is used in every single file. So if you go to AWS deploy, it extends from the base HTML. I basically reused the header and the footer, so that's why I created a separate base.html, and I just extended into each of the HTML files. Again, this references our form for the form fields. I hope that makes sense. That was the nitty-gritty details of the back end of how it works. And now let's actually do some testing.